I want to talk a little bit about the tile-based graphics and why is it more efficient to use compared to sprites in certain systems. So I'll start with a simple example and we'll see why it's more efficient. So a tile-based system on its basis relies on very primitive tiles, and these primitive tiles will have certain shapes, and if you combine them next to each other they will create some sort of a more complicated shape. And in here, I'm showing you some sort of a graphics or a system that can generate some square waves with certain frequencies, and you can, or the shape of square waves, not necessarily a square wave, but the shape of the square wave. So in here, I'm showing you a few of these primitive tiles, specifically 4 of them. Each one of them is actually 4 pixel wide, and it actually has 16 pixel height. All of them are like that, and they're primitive because each one of them show me a very specific shape. For example, the first one in here is showing me a steady 0. This is showing me a transition or an edge from 0 to 1, or what we call a positive edge. And this one here is a positive 1 or a steady 1, and then one here is actually the transition or the negative edge transition, which you move from 1 to 0. So basically each one of these tiles, since I have 4 of them, I can just code them separately. And because I have 4, I only need 2 bits to code them. So I just gave them these particular codes. Simple enough. So now what I can do is I can create some sort of, or on my screen, I'll create a 2-dimensional grid. And in this case here, I'm just going to, for the sake of simplicity, it's just 1-dimensional, but you can imagine that I expand this for the whole screen. So in here, I'm showing you a tile, basically, a bunch of tiles, or grid, not tiles yet. And in this grid, I can place certain tiles. So if I took this particular tile in here, I can just place it in here. I cannot place a tile in the middle of the grid. It has to fit within a certain location. And then what I'm showing you in here is that I decided to put the primitive tile 0, 0 in here, 0, 0 in here, 0, 1 in here, 1, 1 in here, 1, 0 in here, and so forth. So I placed these tiles randomly. At this point, you might not see how this figure would look like. So if I actually scroll down a little bit, I'll see that this is how it will look like. Basically, so if I took, this is 0, 0, this is another 0, 0, and then there's 0, 1. Let's see, it's 0, 0, 0, 0, and 0, 1. So it looks, now I basically created this more complicated shape from very primitive tiles. So now, taking a look at the number of pixels that we utilize, each one of the tiles is actually 4 by 16, and the shape that I was able to actually create is 64 by 16 pixels. If we did not utilize the tile-based graphic system, and I wanted to basically store this or generate this particular shape in here, I would need 64 by 16 pixels. Of course, each one of these pixels would have a color, but for the sake of simplicity and for calculation, we're going to assume that I only have 1 bit per pixel, because that pixel could be either 0 or 1, basically either black or white. Okay, so the total number of pixels in here, which we can calculate very simply, I think 64 times 16 is 1024 pixels. So I need 1024 pixels. Each one of them is 1 bit. So I need 1024 bit to actually store this particular system. So now let's explore it a little bit further, and let me just show you here. If we actually go back and say, well, okay, since I'm dealing with tiles, let's calculate how many tiles I have. Like, you can count them 1, 2, 3, blah, 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 but an easier way to say, well, okay, I have 64 and 16 in here. Well, the 64 is actually the X in here, which is basically the width. So what I'm going to do is I'm going to divide it by 4, okay? And I have the 16 in here, which is the height, and I'm going to divide it by 16 because each one of these tiles will take that particular size. What I'm trying to say is, like, how many tiles can I fit in this particular dimension? How many of these 4 by 16 tiles can I fit in 64 by 16? And the answer is the following. It's actually 16 by 1 tiles. Okay, so 16 by 1 tiles. So technically I can, I need 4 by 16 and 16 by 1 tile in here. Okay, good. So now I'll go a little bit deeper into it and calculate. Well, how can I store these particular basic shapes or primitive tiles? Well, I can use whatever we use for the sprite sheet. It's exactly the same. I'll take this one in here and store it, and I'll take the one right after it and store it, and then I'll take the one after it. And I would need some sort of RAM, or even ROM if it doesn't change, but the actual size for it is actually 2 to the power 2 for the 4 pixels times 2 to the power 4 for the 16. So technically it's 2 to the power 2 plus 4. Okay, and because I have 4 shapes and 4 basically, I need 2 more bits. I will have to add, let's add these 2 bits in here. So technically, I would need this particular amount of pixels, basically, or bits. So the size of the RAM would be this way. And of course, I'm saying, well, I'm storing this in one line, the next pixel in one line, the next pixel in one line. And since I'm just defining it as a single bit, whether it's black or white, I'm just basically multiplying it by 1. So this is the total size of that RAM that we need. And if we calculate that particular size is 2 to the power 2 plus 2 plus 4, which is probably 256. Yes, it's 2 to the power 8 basically, which is 256 bits. So now this particular RAM will take 256 bits. So now let's see, how do I store this particular grid in here? I don't have to store every pixel. I only have to store, well, I need 2 to the power 4, which is 16 tiles, okay, times 2 to the power 0. And so the total is 2 to the power 4, and each one of them will be 2 bits because I'm storing here's 2 bits, here's 2 bits, here's 2 bits, here's 2 bits. So I need some sort of a memory that is basically 2 to the power 4 by 2 bits each. And if you calculate that, that's basically 2 to the power 4 is 16 times 2, it's actually 32 bit. Now, in order for me to store that particular shape that we computed a few seconds ago to be 1024 bits, all I needed to do is actually store 256 in here plus 32, and if you add 256 plus 32 you will get 288. So 256 plus 32 equals 288 bits to store the same exact shape. And now this is why a tile-based system is a lot more efficient. So I can generate the same exact tile, which is this one in here, either using 1024 pixels or bits actually, or using 288 bits. And that's why we use the tile-based system, because it's a lot more efficient. And we were gonna actually employ this particular idea to build a whole on-screen textual display system. The bottom line I want you to get from it is the following. The system will be based on a couple of things. It's actually a RAM or a memory module in here and another memory module in here, and that's about it. All we're going to do is we're going to take these two and we're going to connect certain signals to actually figure out the addresses within them, and that's how the whole core is actually built.